Okay, number 2 says Casey thought that using a pattern would help her understand how to calculate the product in a decimal multiplication problem. Complete the table. This is a question that we're going to discuss in class together, but you need to finish it. Really closely examine this table because we're going to talk about this. This is more related to the strategy that I showed you earlier as it relates to place values and powers of 10 and moving the decimal point to the right or left as you find the answer. The product, remember, just means the answer. So for 32 times 100, you would write the answer here in this box. And so just complete the table, then describe any patterns that you notice, any at all, and write all of those down in that box right there. The next number here says, use the fact that 26 times 31 equals 806 to calculate each product. You can see I've done a few of these. First one I used Kenny's method, and I said this is about 3 and this is about 30. 31 is about 30, 2.6 about 3, so that's about 90. So I can say 806, I can put the decimal point right here in 806 because it's closer to 90. That's Kenny's method. Now my method that I showed you earlier, that I introduced you to, says, well, 806, there's 2 decimal points, 1, 2. We need to move it to the left 2 spots from 806 to be 8.06. Checking it with Kenny's method, 3 times 3 equals 9. That's about 806, so 8.06, so that's correct. Now you could write 806 for all of these right away, and then just move the decimal point where you need to. So if you're using my method here, you'd say 1, 2, 3 place values. So 1, 2, 3.806. Checking it with Kenny's method is a little bit harder here. You would say 0.26. Well, where do you round that to? Well, you could round it to a half or 0.5 and multiply it by 3, and that's going to get you, about 1.5. It's close to that. It's certainly closer to 0.806 than it is 8.06 or 80.6. So you could probably do it there, but you can see it gets a little harder using Kenny's method. So you're definitely going to want to know both methods and understand them both to determine which one is going to help you with that problem and help you make a good decision and become more efficient. I here says, how can some of the problems have the same product? So some of the problems up here are going to have the same product. How is that possible? So explain your reasoning. Jay says, how can you tell without multiplying which problems will have the same product? So there's a way to tell. It's all related to the place values here. Let's look at that. Does any of them have the same place values, total place values, all the way around? Well, this has 1, this has 2, and we're talking right at the decimal point. This has 3, this one has 3. So let's look at this one right now. This actually is going to be the exact same, 2.6 times 0.31, 0.806. So these are the same. All relates to the place value. So you can tell without even multiplying which ones are going to have the same product. Okay, number 4, we'll continue on the next video.